In this video, I want to have a look at graphing our three trig functions. So we're going to start off with sine. Now, in one of our earlier videos when we were having a look at the unit circle, we found out that sine is equivalent to the y-coordinate of the point that's on the circumference here. So if we have this point, we can see that the y-coordinate is 0.5. So the value of our sine function is going to be 0.5 at that point. So if we start down at 0 degrees, we know that the y-coordinate of this yellow point here is 0, so our function is going to start at 0. Now, as that angle increases, our y-coordinate increases as well. And you can see it starts off increasing pretty quickly, and then it sort of slows down as it comes towards the top of that circle. And it's going to keep increasing though until it reaches 1. So it's reached the top of that circle with a y-coordinate of 1, and now it's going to start coming back down the other side. So write down until we reach 180 degrees when our y-coordinate is 0 again. So sine at 0 degrees is 0. It increases until it gets to 90 degrees where it has a value of 1, and then back down to 180 degrees where it's 0 again. Now if we keep going, we're going to drop into these negative y-coordinates. So our sine function is going to become negative as well. So we can see what that looks like as we move around. Comes all the way down until it reaches 270 degrees where its y-coordinate is -1. So the value of sine at 270 is -1. And then it comes all the way back up to 0. So that there is the curve of our sine function. Now we've only gone between 0 and 360 degrees. If we were to keep going round and round our circle, that sine wave would continue forever. Same thing if we went clockwise instead around our circle, so we went into the negative angles, this sine wave would continue over there as well. So that's sine. Let's have a look at cos. Alright, so again, when we were looking at our unit circle, we found out that cos was equivalent to the x-coordinate of our point on the circumference. So for example, for this point here, the value of sine 30 would be about 0.866 because that's the x-coordinate of this yellow point here. So if we start at 0 degrees, the x-coordinate of that point is 1. So our cos function is going to start at 1 here. So at 0 degrees, cos has a value of 1. Now as that angle increases, you can see our x-coordinate is moving in, so it's decreasing. So it's going to continue decreasing until we reach 90 degrees, where the x-coordinate is equal to 0. Then we're going to cross over to the left-hand side of this into the second quadrant where our x-coordinates are negative. So that means our cos graph is going to drop below that line all the way down until we get to an x-coordinate of -1 at 180 degrees. So if we started at 1, come down to 0 at 90 and drop to -1 at 180 degrees. Then as we move around to 270 degrees, we're going to come back closer to an x-coordinate of 0, so our cos function has a value of 0, and then all the way back around to 360 to where we started, back up at 1. Okay, same thing with the sine curve. We've just gone from 0 to 360 degrees, but if we were to keep going, that same curve would continue forever and into the negatives as well. So that's sine and cos. Let's have a look at tan. It gets slightly more complicated. Okay, so to graph our tan function, we're actually going to use our sine and our cos functions. So thinking back again to our unit circle video, we discovered that tan theta is equal to sine theta divided by cos theta. So we're going to use that fact and use our two graphs to help us find some information about tan. So if we start at 0 degrees here, sine is 0 and cos has a value of 1. So we're going to go 0 divided by 1, which would just be 0. So tan is going to pass through this point here. If we look at our next nice point, is going to be at 90 degrees. So sine was 1 and cos was 0. So now we've got 1 divided by 0. But you can't divide something by 0. It doesn't work. It's undefined. So that means that tan is undefined at 90 degrees. And when that happens, it's what we call an asymptote on our graph. So we're going to draw that in with our dotted line. Right, our next nice point was 180 degrees. So we've got sine was 0 and cos was -1. So we've got 0 divided by -1, which will just be 0. So we're going to pass through here. 270 degrees, we had sine was -1 and cos was 0. So we're going -1 divided by 0. Again, we can't divide by 0, so it's undefined there. So we're going to have an asymptote. And the last one is 360 degrees. So we've got sine was 0 and cos was 1. 0 divided by 1 is 0. All right, so there are all our nice points. And at the moment, our graph isn't looking much like a graph. We've got 3 points and we've got 2 asymptotes, and that's it. So what I would like you to do is pause the video for a minute, put in some extra numbers in here, like 30, 60, 80 degrees, 100 degrees, 120. These are just suggestions. You don't have to pick those ones. Pop a scale up the side. So I made it that one box was 1 unit. You can make it 2 if you want. And then put these values in your calculator. So type in tan 30 and sketch that point, tan 60 and sketch that point, and see if you can figure out what's going on. So what you've hopefully ended up with is a couple of points that look something like my blue ones here. So then you're going to join them together. We know that the lines or the curve is never going to touch these asymptotes. It's just going to get infinitesimally close to them. So we're going to draw it coming up here and coming close, but never actually touching. Now, when you're drawing your graphs, you're always drawing them in pencil. So you can hopefully get yours looking a lot nicer than I can get mine on this tablet. But it's going to come up through there and coming up like that. Then this one's going to start down here, curve up until it reaches that 0, and then curve back the other direction. And this one's going to curve down this way. Okay, so that's what our tan function looks like. There is a more accurate version, a precise version of your tan graph in your textbook as well that you should have a look at. But that's just a quick video looking at the sine, cos, and tan functions.